In this lecture, we are going to see that we can actually steal from L values with a special facility we have in C++, which is stdmove. To learn about this feature, we're going to set up a swap function, which is going to be swapping objects. So for example, if we have x and y, and for example, we have a 10 in x and have a 12 in y, if we swap this, we would store a 10 in y and store 12 in x and swap the values we have in these guys. This is what we want to achieve. And one way we can do this is to set up a temporary object which is going to hold one of the values. For example, we can get the value in A and store that in our temporary object. Then we can take what we have in B and store that in A, and then override what we have in B with the value we have in our temporary value. By the time this function runs, the data is going to be swapped. And if you print what you have in A and B, you're going to see that the data has basically been swapped. This is going to work really well. This is going to swap your data even if you use this function on box container objects like we are doing here. This is going to work. The problem is, the way these things are working now, they are going to invoke copy constructors and copy assignment operators, and we know that these copies are really bad. In copy constructors and copy assignment operators, we saw that there was potential to do a lot of dynamic memory allocations, and dynamic memory allocations are really expensive. If you do a lot of them, you're going to slow down your program. Another thing we do in these copy constructors and copy assignment operators is loops to copy data from source object to destination objects, and we don't want to do that. But if you look at what we have in our swap function here, we don't really want to do these copies. What we want is to move data from one object to another, and we really want to steal from objects. For example, when we do the setup we do here to build a temp object from A, we want to steal the data we have in A and avoid all those dynamic memory allocations and all those copies. We don't want to do those. And if we use our copy constructor, we would be able to achieve that. But the problem is, A has a name. You see, it is a parameter here. It has a name. So it is a null value. And when the compiler sees this line here, it is going to see that A is a null value. And this construction we are doing here is going to use a copy constructor, and it is going to do copies that we don't want. For example, after this line here runs, we will have the same data in A and B because all we did was really copy data from A. So A is going to still have the same data, even if we don't really want that. When we do the assignment here, this is going to be doing copy assignment, and after this line here runs, we're going to have the same data in A and B, and this is really what we don't want. We want the data to move from B to A, and the same is going to be happening on the last line here. When we do the assignment, this is going to be using copy assignment. So we will have the same data basically in B and temp, and we don't really want to do that. So this is going to do what we want. If we run the code after the function call, we're going to see that the data has been swapped, but we don't want to do all those copies to improve on our performance here. So one thing we need to do is to tell the compiler that we don't want copies, we want moves, and we tell the compiler to do a move by wrapping our calls into an stdmove. So what we do here is, if we create our temp object, we tell the compiler that we want to move from A. This is what we mean here. When we assign it to A, we say that we want to move from B. So the data is going to move from B to A. When we assign it to B, we want to move from temp. So the data is going to move from temp to B, and we will steal from the temporary object here and move the data into our B object. This is going to work really well. The data is going to move permanently because we are using references here, and this is going to work really well. Okay, one thing you should know is that stdmove doesn't move data itself. All it does is to tell the compiler to treat your object as a nar value, and the way it does that, it is going to cast the object to a nar value. What is going to trigger the moving of data is if we try to do a construction from a nar value, or if we try to assign the resulting R value through an assignment operator. That's going to trigger the moving of the data, but the stdmove call itself is not going to move your data. Now that you know these things, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is Moving Lvalues with stdmove. We will reuse the code from the last lecture, so let's grab everything from there and put that in our current project. And we are going to open this little bad boy in Visual Studio Code by dragging and dropping here. This is going to set up our box container class exactly like we had it in the last lecture. Let's hop over to the main CPP file and change things up a little bit. Let's remove everything we have in our main function. We are going to keep our make box and populate box functions here. We are going to put in our swap function, which is going to swap data exactly like we saw in the slides. But note that this is going to do copies. So on line 21 here, we will call the copy constructor. On line 22 and 23, we will be calling our copy assignment operator. You should know this. I don't think we will need the make box function here, so we can safely remove it. And we can hop over in the main function and set up a few box container objects. We're going to print them out and we will try to swap them up using our swap data function here, and we're going to see what we get. We print box 1 and box 2, we will see the data, and if we print them again, we're going to see that they have been swapped as a result of the call we have on line 30 in our C++ program here. We can pass our program through a compiler. Let's use GCC. The build is going to be good, so no problem here, and we can bring up a terminal window. And if we run roster, we're going to see that the data we have in our guy is 15, 30 in box 1. That's the data we have in box. This is box 2. So let's make sure we see the entire thing. So we have box 1 and the data we have is 2, 4 and whatever. In box 2 we have 15, 30 and whatever. If we swap them up in box 1, we will have the data we had in box 2, and in box 2 we will have the data we had in box 1. But notice that this is going to call our copy constructor and copy assignment operator. Let's make sure we see these things. So we're going to bring up our terminal window again, and you see that the copy constructor was called to copy 20 items. We have the copy assignment operator called to copy data. This is not really what we want. We want to move data. And the problem is that what we have in our swap function are L values. A and B are L values. So if we try to copy from A, we will be doing a copy. We won't be doing a move. The compiler will see that this is an L value and it will trigger a call to the copy constructor by default for this line here. For line 15 and 16, the compiler is going to see that A and B are L values, and it will trigger a call to the copy assignment operator if we do these things we do on line 15 and 16. For this to use our move versions, we need to tell the compiler to treat these guys as R values. And we do that by wrapping these guys in an stdmove call. Let's do this. We're going to say stdmove. Or I don't think this is a good strategy. We can comment out the copy version we had and set up a move version. I think this is going to be self-documenting for this example here. So let's copy what we have and we're going to go down and say move version. This is going to be much better. And we will wrap our things in stdmove calls. And we're going to say stdmove A. This is going to invoke the move constructor because we just told the compiler to treat A as an R value. So if we try to construct from an R value, this is going to invoke the move constructor. We're going to treat B as an R value here. So we're going to say stdmove B. This is going to invoke the move constructor, the move assignment operator, I should say. And we're going to say stdmove from temp. And this is going to trigger a call to the move assignment operator. And this is going to do what we want. The trick is to notice that A and B are L values, and they are L values because they have a name here. So they are L values. We can grab the addresses. We can do all kinds of crazy things with them. But because we really want to move data here, we need to tell the compiler to explicitly treat A and B and temp as R values and completely move data from these objects if we do construction or assignments that we are doing here. So the moment we do this, if we do a swap, we're going to see that what we see are not calls to the copy constructor or copy assignment operators. These things are going to change to invoke the move constructor and the move assignment operator. And this is really what we want. Let's hop over to the box container class and see that we have proper output statements in our move constructor. But I think we do from the last lecture. So let's try and run this and see if it actually works. We're going to pass this through our GCC compiler. The build is going to be good, so we can clear and run Rooster. We're going to see that the data we have in our things is for box 1, we're going to have 2, 4, and whatever. For box 2, we will have 15, 30, and whatever. And if we go down, we see that we are calling our move constructor because we have told the compiler to move from these objects if we do a construction or an assignment. And if you go down, you see that we have triggered a call to our move assignment operator, and we are not doing any unnecessary copies. And this is really cool. This is going to speed up our program significantly, especially if we are calling this function a lot in our code. This is really all I had to share in this lecture, showing you that it is possible to treat L values as R values. And you do that by wrapping your L value in an stdmove call. stdmove is not going to move the data by itself. All it is going to do is to tell the compiler to treat your L value as an R value. And if you happen to construct from that thing or assign from that thing, the compiler is going to either trigger a move constructor or a move assignment operator, and you are going to move data exactly like we did in this lecture. And this is really cool. We are going to stop here in this lecture. In the next one, we are going to zoom in on the invalidate call we did and really make it super clear that you need to remember to invalidate your temporary objects after you steal data from them. And this is what we did, but we're going to zoom in on this a little bit and really make this super clear. So go ahead and finish up here and meet me there.